Hello, math friends. Today we're going to take a little look at how you can solve multi-step inequalities. So we're going to really put all of our good algebra skills to work all at once. So let's just go ahead and take a look at a multi-step inequality. This would be an example right here. 3n plus 6n minus 9 is greater than or equal to 8. And when I'm solving this inequality, I really can think a lot about it, quite a bit like an equation. So if I just think about it in terms of the equation, I would start by combining like terms. So I think about my inequality sign kind of like my equal sign. I do 3n plus 6n gives me my 9n minus 9 is greater than or equal to 8. And now I look and I would think, how would I normally get my n all alone, which is my goal? I would start by moving a plus 9 to both sides. And that works, it's just fine. I end up with 9n is greater than or equal to 8 plus 9 is 17. And then I would have to divide by 9 on both sides. These cancel and I get n is greater than or equal to 9 fits inside of 17 one time with 8 left over, and 1 and 8/9. So my solution to my inequality would be n is greater than or equal to 1 and 8/9. This works out great, and it's super good algebra, combining like terms. Really it's a lot like solving an equation. It's just that my answer can be any number greater than 1 and 8/9, which is pretty cool. There's one situation where we have to be careful, and this is the one. When you flip, you have to flip the inequality sign when you multiply or divide by a negative number. So we're going to take a look at one where that happens. Okay? So if we look at this, we're going to start with 3 times the quantity 5 minus n is less than negative 6. And we're going to go ahead and start by using the distributive property. So if I use the distributive property and I distribute my 3 through, I get 15 minus 3n is less than negative 6. Now I go ahead, I think about it like an equation, and I subtract 15. I'm still safe. I haven't multiplied or divided by a negative yet, so all is well. I get negative 3n is less than negative 6 minus 15. I'm going to chop here. It's going to give me negative 21. Okay, and now I'm going to go ahead and I have multiplied by a negative 3, so I'm going to have to divide by a negative. When I divide by that negative 3, my inequality sign is going to have to flip. So instead of n being less than, n is going to be greater than. Negative 21 divided by negative 3 is 7. So my solution to my inequality is n can be any number bigger than 7. So that's awesome, and it looks cool, and you think, Mrs. Bruner, how do you know this crazy rule that keeps going in and out and distracting my math? And let me tell you a little bit about why I know. One way to kind of explore it a little bit is if you write an inequality that you know is true, like 5 is less than 8. And now let's just look at what happens if we multiply by a negative number on both sides. If I multiply by a negative 2 on both sides, I'm going to get a negative 10 here, and I'm going to get a negative 16 here. And now if I think about that, what inequality sign would make that true? Well, negative 10 is greater than negative 16. Look at that. I flipped my inequality sign. And so if I start again with a totally different problem that I know is true, like let's say I know that 10 is greater than negative 6. Okay, and I'm going to use division this time of a negative. If I divide both sides by negative 2, let's see what happens. 10 divided by negative 2 is going to give me a negative 5, and negative 6 divided by negative 2, you can probably already predict it, is a positive 3, and look at what happens. Now, negative 5 is actually less than 3. My inequality sign flips. So by using this little example to kind of examine it with multiplication and division of negatives, it shows that, hey, that inequality sign has to flip in order to keep my problem true. So when I look at a problem like this, and I get to this step where I'm dividing by that negative, hopefully it makes a little bit more sense of why I would have to flip that inequality sign. So that's how we have it, but man, you got to have your algebra on when you're doing these problems, because you got to combine like terms, you got to use the distributive property. You're using your inverse operation all over the place on these. This is good math. You are super rock starring it out if you can solve these problems, but just remember this rule, because this is where it gets a little tricky. Flip that inequality sign when you multiply or divide by negative. Woo!